All right, now our last topic here is to take a look at energy. So energy, according to physics, the definition of energy is the ability to do work. All right, that's the definition of energy. And energy also cannot be created or destroyed, only changed in form. So the definition of energy from physics is the ability to do work. If you look in a physics textbook, you look in the dictionary, it says it's ability to do work. Okay, energy also cannot be created or destroyed, only changed in form. There are two kinds of energy. There's kinetic energy and potential. All right, we have two kinds of energy, kinetic and potential. So here's an example, a diagram from your book. If you look at this, potential energy is, so this is actually converted, this is going to be kinetic energy being converted to potential energy. So this is the maximum, and then you have kinetic energy here coming down. Kinetic energy increases. All right, so that's an example of potential energy at its maximum, and then it's going to go down here because it's overcoming gravity. Why it's potential energy? Because you're overcoming the pull of gravity to this point here, which gives a maximum point, and then you're going to go down here to relatively zero. So potential energy is stored energy. It results from position or composition. Kinetic energy is the energy matter has as a result of its motion. So kinetic energy is energy of motion. And energy can be converted between the two types, which we just saw in that picture. A boulder at the top of the mountain has potential energy. If you push it down the mountain, the potential energy is converted to kinetic energy or energy of motion. Now you have an example here in your book about, since we're talking about states of matter, an important relationship is kinetic energy, temperature. So in how the theory, okay, so now we're talking about theory. The theory is the energy of motion for kinetic energy are molecules moving. Okay, molecules, if you take a bowl, it has molecules in it. All right, so we're going to look at how does temperature affect the kinetic energy and physical states. So one of the things is that all substances have energy of motion, regardless of their state. Even solids have a type of kinetic energy called vibrational, where they're sort of vibrating back and forth a little bit. Okay, they have a little bit of motion. They have to have some kind of motion. Now they have the lowest kinetic energy, and gases have the greatest kinetic energy. So if you go back to lecture number 2, where I was talking about the property of gases and the skunk, where if the kinetic energy of the gases, the skunk, they have a lot of kinetic energy so that the molecules move far away and you can smell them over great areas. So in general, as the temperature increases of a substance, its kinetic energy increases. So one of the things that we say in chemistry is kinetic energy is directly related to temperature. So if the temperature is going up, the kinetic energy is going up. If the temperature is not going up, then the kinetic energy is not increasing. All right? So if you're heating something, for example, melting ice, and you're adding heat to it and the temperature isn't going up, then all that energy is being converted to potential energy. So that's a good way to know. That's a good trick to know. If the temperature is going up, the kinetic energy is increased. If you're adding heat and the temperature remains constant, we'll be doing that in lab next week. If you add temperature and the temperature remains constant, then the kinetic energy is not going up. The potential energy is going up. So down here at the bottom, we have table 3.7, properties in physical state. So here's kinetic energy, like how the molecules are moving. In the solid state, you have relatively low kinetic energy. You have very little movement. In the liquid state, I don't know if we'd say high in the liquid state. I'm not sure we'd say high there. I'd say that. I'd say medium. And it's somewhat restricted. You have another type of motion with liquids called rotational, similar to the Earth rotating on its axis, so the molecules can spin. You have vibrational, where they're sort of vibrating, resonating. Then you have rotational, where they're spinning, like similar to the Earth. And then you have gas, unrestricted, which means they have high kinetic energy. And just go back to the example of perfume, spraying perfume. Why those molecules? You can smell the perfume in the back of the room is because the molecules are moving rapidly, and they can fill up the space that they have. So now the law of conservation of energy. Just like matter, energy cannot be created or destroyed, but it can be converted from one form to another. That's called the law of conservation of energy. There are 6 forms of energy. All right, there's heat energy. You need to know these: light, chemical, electrical, mechanical, nuclear. You could say sonar. That would be, I think you could do sonar, would be another type of energy. So these are the forms that, the two kinds are potential and kinetic, and then you see them in heat, light, chemical, electrical, mechanical, and nuclear. All right, this is energy and chemical change. So if you're looking at this, this is a chemical reaction, water breaking down into the elements hydrogen and oxygen. So in order for that to take place, energy has to be absorbed. If you have hydrogen and oxygen coming together to form water, then your energy is released. So this is an important sentence at the bottom. The conservation of energy law states the following: electrical energy absorbed equals heat energy released. So this is two different forms. So you have electricity. Electricity forms, energy is being absorbed to give you the elements hydrogen and oxygen, which are molecules. Then if you take hydrogen and oxygen and you just give it just not much, just a spark, that's all you have to do, it will give an enormous amount of energy release, and it forms water plus heat energy. So we used electrical energy up here, which is one form, and down here what we got out of it was heat energy. So that's pretty cool. Okay, so we got electrical energy being converted into heat energy. All right, now this is the final, this is Einstein's equation. Einstein's one of my heroes. Einstein's great. So this is what he said. He said mass and energy are related by Einstein's theory of relativity. This is a law, okay, natural law. This is energy. It's equal to mass, like you know mass, okay, matter. And this number here, c, is the speed of light squared. All right, and the speed of light is a very large number, and you square it. So a little tiny bit of matter can be converted into an enormous amount of energy. And that's what happens in a nuclear reactor. You take very, very small amounts of matter and you convert them into large amounts of energy. So nuclear energy, in terms of a source of energy, is an enormous, powerful source for energy. Theoretically, it's a great source of energy. The problem I have with it is safety. And once you get businesses trying to make money with it, it's just, it's not, I wouldn't live near a nuclear power plant. That's it. I wouldn't live near one. So mass and energy can be interchanged. One of the things I like to say is that all matter is, if you take energy, all matter is compressed energy. So if you take energy and you compress it and compress it and compress it and compress it and compress it, eventually you'll get to matter. So that's all matter is. It's just compressed energy. So now we have the law of conservation of mass and energy. Okay, we no longer have just mass or just energy, and it states that the total mass and energy of the universe is constant. There's no loss. It's constant. The whole thing is constant. All right, so this is the chapter summary. Matter exists in three physical states. Substances can be converted between the three states. That would be physical changes. Substances, that means matter, can be mixtures or pure substances. Pure substances are either elements or compounds, okay? Mixtures are physical combinations of elements or compounds, but pure substance can only be an element or a compound. How we arrange the elements are in the periodic table. Every element has a name and a 1 or 2 letter symbol. Elements are classified as either metals, nonmetals, or semi-metals. Physical change is a change of state. Chemical change is you change the composition. Both mass and energy are conserved in chemical changes. And then you have the Mastering Chemistry homework. I recommend that you go to, this is the end of the chapter, okay? So you go to Mastering Chemistry, start at exercise 334, and it goes up to the end of whatever the assignment is. All right, so that's it. I hope that it was helpful to you. I enjoyed doing it. So that's it. I just did this mistake. Okay.